Hello, welcome back. In this video, we're going to go over an exercise for finding the derivative of a function. And the derivative at the given point is going to define the slope of the tangent line. The function here is radical x minus 1, and the point is 5 and 2. So by finding the slope of the tangent line together with the point form, we can write down the equation of the line. But at this moment, I want to step back and remind you what the relationship is between the slope of the tangent line to a function at a point and the derivative of the function. This expression here is the derivative of a function at point C, and that's in fact the slope of the tangent line passing through the point C and f of C. And essentially for this problem, we're going to evaluate this limit, and whatever the value of that limit is, that's going to be the slope of the line. C in this problem is going to be 5, and this expression is going to be equal to the slope of the tangent line. So our next task is to simplify this rational expression. Okay? So at this moment, we're going to do function evaluation for the top. So essentially, I'm going to replace x by 5 plus delta x in this expression. So in other words, I'm going to have 5 plus delta x minus 1 minus f of 5. So x is 5 here, so it's going to be radical 4. And the bottom is going to be delta x. So at this moment, you can stop and check the limit. Well, since delta x approaches 0, the top approaches radical 4 minus radical 4, which is 0. And delta x is already approaching 0, so this is 0 over 0. This is one of the indeterminate forms we run into in chapter 1 in the limit calculation. And to go around that, we have to find an equivalent form of this expression. In other words, we should simplify this expression. Remember a trick from pre-calculus. Essentially, if we have the difference of two terms at the top, especially that involves radical expression, we generally multiply the top and the bottom by the conjugate of this expression. So let me just write it here. So the conjugate of this expression is the plus version of the top expression. So it's the difference of two terms, so it becomes the sum of these two terms. So we multiply top and the bottom by that. All right, so the 4's here are canceled out. And then at the top now, I'm just left with delta x. In the bottom, we have delta x times this expression. So the good news is that I can divide top and the bottom by delta x. So at this moment, we stop again and check for the limit. So since delta x approaches 0, this term is going to approach 1 over radical 4 plus radical 4. So the limit exists. So I can conclude here that this is equal to 1 over radical 4 plus radical 4, but radical 4 is 2. So 2 plus 2 equals 4. All right, so 1/4 is a meaning. This is the slope of the tangent line to the curve at 5 and 2. To be able to write down the equation of the line, we recall the point slope form of a line, which is essentially y minus the y coordinate of the point, that's 2, equals the slope 1/4 times x minus the x coordinate of this point. All right, thanks for watching. I'll see you in another video. Bye.